edition of CamLogic's Tech Tuesday. My name is Joshua Ponzetti and I'm the Solid Edge Application Engineer at CamLogic. Tech Tuesday is our free weekly 30-minute tips and tricks webinar. Today's topic is synchronous sheet metal. Let's start off really quick with talking about who CamLogic is. CamLogic is a leading provider of PLM solutions, 3D scanning and rapid prototyping technologies and services to help companies design and build better products, improve processes, reduce costs, and maximize profitability. You can see that we have a proven track record with 16 plus years experience, and there's a few other pieces of information there on the slide to help you conclude those facts. Let's talk a little bit about our technologies. We provide unparalleled 3D engineering technological solutions along with the services and support to ensure our client success. You can see that we have 3D scanning, CAD, CAM, CAE, 3D printing, and rapid prototyping up there on the slide for you. CamLogic is a Siemens PLM Solutions partner. We offer the complete Siemens software suite including NX, Solid Edge, VMAP, and Teamcenter. We also provide a complete array of 3D printing hardware and services solutions including the 3D Systems projects or series and the Z printer series, being the most affordable color 3D printer on the market. 3D scanning technologies rounds out our trifecta of engineering solutions, from state-of-the-art hardware like Romero Absolute ARM, Shape Grabber, and Z Scanner, and cutting-edge time-saving inspection and reverse engineering software products from Geomagic and RapidForm. CamLogic is here to provide a variety of solutions to meet your business challenges. We also offer professional, high-quality, in-house training services. So let's go ahead and get into today's lesson and start talking about what we're looking to accomplish here in the synchronous sheet metal environment. In talking with a lot of my customer base, I know that there's a lot of our customer base that does use sheet metal. Most, I believe, are still in the ordered environment. I had an opportunity to work with some in the synchronous environment, and so I thought Tech Tuesday would be a good topic to explore some synchronous sheet metal. So let's talk about what we're going to get into today. We're going to go ahead and look at creating some tabs and flanges. We're going to touch on the bend jaw command. We're going to create some cutouts, holes, some procedural features. So again, that is deformation features such as dimples, louvers, and gussets. And then we're going to go ahead and produce a flat pattern and also create a bend table. All right, so let's go ahead and get into this. All right, flipped over to Solid Edge. I'm just in a sheet metal file in that environment. And the first thing I'm going to do is point out our sheet metal tab that we have here on the ribbon bar. So on the sheet metal bar, you can see that we have a series of commands, and we're going to try and explore all of them and touch in all of those through the synchronous environment. So the first thing I'm going to do is I'm just going to come up here and begin sketching like I normally would in the sheet metal environment. But before I do, I'm going to go ahead and hop out of that. Let's go ahead and begin with establishing our material table. So now we're in here in our material table. The first thing I'm going to do is go ahead and grab steel to be my material. And then I can come on over here to the gauge tab and then apply a gauge I want to work in. In this case, I'm going to choose 14. And you can see that it applies some standards, defaults to material thickness, bend radius, a couple other options. Again, we're just saying, hey, Solid Edge, let's play by the rules here. So I'm going to go ahead and apply that. Now that will apply to all of my efforts that are going to happen in the sheet metal environment, just like it did in the order. So I'm going to go back and begin sketching again. And the first thing I need to do is lock to a plane. Once I get locked to a plane, I can go ahead and sketch on that plane, and it don't have to be normal to that surface or normal to that plane. If you ever wanted to, here's a little tip down here in your quick access bar, you have sketch view. If you were to click that, it'll pull your sketch and orient it normal to you on the screen. In this case, I prefer to work just in a skewed sense of an isometric view. So I'm going to go ahead and, again, just paying a little bit of attention to my command bar up here, I'm going to go ahead and start typing in value. So I'm going to go with a 10 by 10 and put my rotation angle at 0. So now I've created my rectangle. It's fully constrained, and you can see that it included all the relationships. So now all I need to do to create my tab from that is just go ahead, select that region, and begin pulling my tab in a direction. You can see it's adding the thickness and giving me a look at that. If I want to reverse that direction, I could just click the arrow. It reverses it into the opposite direction, but in this case I want to come up, so I'm going to click to place, and now I have my tab created. Next thing we're going to do is we're going to throw some flanges on this, and Synchronous makes it quick and easy. It's simply selecting the face, and then again, a quick tip, hit your space bar to select multiple faces so we can come in and we can grab these 3 faces. Now I'm going to rotate back so we have a nice view of this. Once we grab our handle, we can begin pulling our flanges down. Now you can see that there's 2 values there that are displayed. We have the value that would consist of the length of the flange as well as the angle. I want to show you that simply by hitting my tab key. I can tab between the 2 values and set them. Right now I'm in the position to edit the 90 degrees. Don't want to. I want it at 90. I'm going to go ahead and type in a finite value of 5, and here I am. 3 flanges created quickly and easily. So now what I'm going to do is go ahead and show you how we can go ahead and we can start placing some dimensions on our geometry quick and easy, utilizing the smart dimension. Now, these are technically PMI dimensions as we place them, but you can see that this dimension snapped to the outside of material, and now I'm going to go ahead and grab another dimension that's going to snap to the inside. You can see that it's holding my 10 inches, which is what I wanted. However, if I ever wanted to go back and say, whoops, I wanted to make the inside of the tabs 10 inches, I can go ahead and set that value. You can see it changed the outside and then set the inside. So we can always do that, but for this purpose, I'd like the outside at 10 inches. So we can go ahead and change that back. Now what I want to do is I'm going to come over here, and I'm going to put a cut in. First thing I'm going to do, this is actually one of the huge advantages in the synchronous environment, one of my favorite things that I like to show my customer base. If I come in and just simply begin sketching, again, I'm locked to this face right here, and I'm going to go ahead and sketch, again, utilizing my relationship handles, and you can see that I'm actually sketching off of the part itself. Okay? Looks like we missed alignments. There we go. Now I'm going to go ahead. I'm going to put a circle on the end of this, just so more than anything, I just want to show that I'm actually going to wrap this cut quick and easy. So if I set that at 1.5 inches, I'll set this at 1 inch. And again, using our usual sketching techniques, I'm just going to go ahead and create some alignment, put it on center of the part. Like so. I'm going to make sure that I'm going to go ahead and trim this out real quick. And we'll trim that, and we'll make sure that we have some alignment on the round part. Okay, so now I want to go ahead and make sure that this is positioned on my part where I want it. So I'd like it 1 inch off of that side. I'm going to come over, create another dimension, coming up, and I want that 2 inches down. So now if I come back and begin selecting my regions, you can see that I now have selected that cutout in those regions, and now what I want to do is I want to wrap that. So first thing I'm going to do is select my direction. We'll come up to my command bar and show you that if we set it for a through next, you can see that it takes that cut straight down. But by simply going back to my ribbon bar, I can hit my wrap cut feature on my command bar, and you can see it went ahead and unbent that flange for me and showed me that, hey, we can go ahead and wrap that cut around that, and gave me almost, well, it's not almost, it's a flat pattern view. Simple right click, cut is wrapped, and we're moving forward. No reason to go back, unbend, cut, and rebend. We'll just do it all at once. Go ahead and clear that command. So now the next thing I'm going to do is I'm going to go ahead and I'm going to lock to the side plane. What I'm going to do is I'm going to put a jog in. So by simply creating a line, again, still locked to the plane. Make sure we maintain some alignment relationships there. Now I can go ahead up to my jog command, grab that line, choose my direction. Now I've created a jog. In this case, I'm going to go about 2 inches out. So now you can see, looking at the back of the flange, we've jogged it out so we have an opening here, and of course it did the same on the front end. So next thing we're going to do is, by utilizing synchronous technology, we can go ahead and we can grab an edge by bringing up, or grab a surface, bring up the steering wheel, put it on an edge, and now I can come in and then begin adding an angle of rotation to that edge. For this, I'm going to go with a finite value of 20 degrees and set it. Let's go ahead and go around to the back. We've got an opening in here. So I'm looking to go ahead and close that up. The first thing I'm going to do is grab this face and begin to create a flange. Okay, I went ahead and created that flange, and what I want you to notice is that flange is going back underneath the part. Well, we want to put that flange in line with this. Again, through synchronous technology, we can come up here and add a parallel relationship to these faces. Works very similar to the sketch relationships. We select our seed face and then our target face, and you can see that it will go ahead and produce that alignment. So now that we have that in line, we want to go ahead and close this off. So what I'm going to do is grab that face. Now, quick tip and trick. Hold the shift key, click the primary axis. Now you can go ahead and produce an offset. I'm going to use 1/8 of an inch, and with another quick click, grabbing the primary axis, it'll now maintain that offset. So as I roll around, I can grab the end point of the existing geometry and make sure that that 1/8 inch gap is maintained exactly how I wanted it. So now let's go ahead and, this is going to be a cover, so we need to get some mounting flanges on here. I'll go ahead and kind of move this under. Again, we're simply just selecting faces, creating flanges, nothing difficult, just moving right along the workflow. So we'll go ahead and set that at a 1-inch mounting flange, except for this mounting flange came off at an angle, and I want this face to be in line with this face and this face like I had went ahead and taken care of before. Again, we can select that face, add a coplanar relationship, and now we have all of that in line on the back half, because perhaps that would interfere with part of my assembly. So now we got our mounting flanges in. Let's go ahead and throw some holes in. I'm going to use the hole command, and again, the first thing we need to do is lock to a face, so we can then begin including the holes. Let's go back to our hole options. We should all be familiar with this. We want to make sure that we have a simple hole. 1/4 inch looks good to me, and so then that way we can just use a standard screw. Again, by utilizing our key points, we can make sure that that we can start creating some alignment and setting our holes. And I'll grab that hole again. You can see the red dotted line. Lets me know I'm aligned, and I can set the next one. Okay. We'll go ahead and clear out of that command. I'm going to go ahead and put holes on the second flange. And I'm going to go ahead and lock to this face. So now, when I create the alignment, I'm going to go ahead and set my holes like I did previously, but now I'm going to show you that we can go ahead and dimension those up and position them where we need them. So the first one I'm going to dimension is this one. Okay. Another quick tip: if your dimension is kind of coming off skewed when you're placing it in a 3D fashion, if you hit N, it'll go ahead and it will toggle to the next position that it can be set. Now, we have a value that we can enter here. What I want to do is point out the fact that this arrow is moving in this direction. So, and it's going to want to move this surface. What we want to do is we want to click on the origin and reverse the direction. So we're moving the hole in relation to the surface, not the surface in relation to the hole. So I'll set this at 1 inch. And you see our hole moves quick and easy, and then we'll go ahead and dimension this hole out. Put it at 1 inch. It was already moving in the right direction, so I didn't point that out. Alrighty, so we got a part taking shape here, everybody. I'll go ahead and select. Another thing I'm going to do is, it's good to point this out, sometimes when you're utilizing the PMI, it can kind of cluster up your part. Now that we've constrained the things where we want them, I'm going to go ahead and turn that off, cleans things up, let you keep moving and working without dimensions getting in your way. So now what I'm going to do is I'm going to focus in this area, and what we're going to do is we're going to throw a dimple in here that has a unique shape to it. And again, the first thing that we're going to do is we're going to come in, we're going to lock to this plane, and we're going to begin sketching. So I'm going to sketch a line. Okay. Another tip: if you're sketching a line and then you hit A, it'll put you into the arc command. So we'll do another one, and we'll go ahead and set another arc. Let's zoom in here and trim this real fast. So now, let's go in and clean up this geometry really quick. Make sure we have nice tangency, lines to arcs, and all that set. I'm going to come in and make a couple lines parallel to one another. We're going to reset this this profile here. Okay, there we go. That looks a little bit better. Okay, now we can go ahead and begin setting these lines parallel. Okay. And now that we have a shape in there, we can go ahead and produce a dimple simply by selecting the region. You can see that it will then give you an offset value and produce the dimple. Let's go and take a look at that underside. So now we have a dimple that's set up kind of based on the part that we were putting it on. Now we were able to constrain the geometry of it based on the sketch relationships and go ahead and get that produced. So now I want to go ahead and I'm going to flip around to this back corner, and I'm going to go ahead and put a corner condition on there. So I'm going to close the tube end corner real fast. By selecting the radii, we can go ahead and you can see how the geometry changed. We're going to go ahead and close that up, and I'm going to allow for a 30 thousandths gap. And then quick and easily we're able to close that up, dictate the gap, and change the defaulted overlapped condition that the flange command created. So now what I want to do, because I'm not mounting this backside down, I want to go ahead and throw some gussets in here. So if I come up here to the dimple command and grab the gusset, I can then grab a radius, and you can see it's already putting the gusset in there and giving me a value of offset. I'm going to come up here into my gusset options. Again, you can save your gussets and name them. For this, I'm just going to go ahead and begin dictating my gusset. So I want to go a ½ inch deep, again tabbing through the dialog box. I'm going to want to go ahead and have a square, dictate my radius at 60 thou. Taper angle will go 10 degrees in, and then ½ inch deep. Then we're going to go ahead, and you can see that I could go ahead and physically place that gusset. Instead, I'm going to come up here to fit, and I'm going to put in a count of 5. Okay, you can see that I only ended up with 4 gussets because the 5th one would technically be in this cutout, but it still helped me to achieve an even spacing both sides of that cutout, adding strength to this piece because, again, it wouldn't be mounted down. So now we have our gussets in there. Now what I'm going to do is I'm going to put some louvers here on the top. So I'm going to come back up to the dimple command, grab a louver. Here's a quick tip. When you go and hover over the surface that you want to put that louver on, if you hit N for next, it will then grab the edge and reorient your louver. And B for back will reorient it in the opposite or back direction. So now, once we go ahead and lock to this face, we can come in and utilize existing geometry for alignment. You can see that I can go ahead and align that louver and place it. So now I have one louver in place. What I want to do is select that louver, and I'm going to go ahead and do a quick pattern of it here in the assembly environment. You can see I have a finite value because I'm set to fit, and I want to change that to 6.5. And you can see here that now 3 instances, within 6.5 inches. If I come back over to my tree, grab the pattern, go and select that pattern text, we can go ahead and alter that. So now I want to bump my Y count to 4, and quickly and easily we are moving along, and now have 4 instances in that pattern, again creating the louver. So, got quite a bit going on in this part. Shaping up pretty well. The next thing that I'm going to want to go ahead and do is we're going to go ahead and generate a flat pattern of this guy so you guys can see that in the sheet metal environment. So go to my Tools tab, select my flat pattern. It automatically defaults me into the flat pattern command. So now if I select that face and then grab an edge, you'll see that it'll flatten out my part for me. You can see it gives you the overall dimensions by default. Flat pattern's there. It bent all the tabs out. You can see it does include some representation of where the bends are. And then, of course, by simply clicking back into the Synchronous, it will then refold the part, and we can go ahead and take a look at it in that state. Now what I want to do is just come on in here again, same tab, we're on the Tools tab, grab the bend table. So by selecting the bend table command, you can see that it goes in, it labels all of the bends, and then includes them in the table. I want you to notice it puts a red box around the bend selected, and also highlights the balloon on the part itself. Also, what you can do is you can select the bend and you can move it up. You can see that 8 turned to 7. Now it's back to 8. Down here in the balloon. So if we go ahead, we can move that up, and we can make that the first bend, and all of our other bends renumber appropriately. And real quick, of course, the beauty of Synchronous is that now that we have a complete part, able to go through all of that information through the flat pattern and the bend command, we can always go back and quickly edit. Again, in the history base or ordered environment, this would perhaps be a very risky change to make. We have to go back through all the flanges, and then we have to worry about the dimple and everything. I'm just going to go ahead and select this face, and I'm going to go ahead and move it because I didn't make it tall enough the first time. So I can go ahead and begin moving that face. And we'll go ahead and click to place. Okay. Now I can come back, and you'll notice that, yep, we left this little flange behind. That's okay. We can come back and grab it. We can utilize the existing geometry that's already available to us based on what we created previously, and go ahead and close that up. So then we did that change quick and easily. We could have also grabbed this face and the top face and moved them together. I just wanted to show you that, again, you can utilize any of the existing geometry that's available to you while working in the sheet metal synchronous environment. Let's go ahead and talk a little bit about what we did here today. We created some tabs and flanges. We included jogs and cutouts. Emphasis on the wrap cut, guys. That's a winner in my book. It makes things quick and easy, and again, by unbending and rebending, one thing I didn't show is it will work with multiple surfaces too. So if you were to take a cut over 3 surfaces that were bent, it would unbend all 3 surfaces. It just detects what the cut will intersect upon wrapping. Included procedural features in the design. We did gussets, louvers, dimple, and a uniquely shaped dimple as well. Added holes to the part. We utilized synchronous technology to edit and create features. We produced a flat pattern of the part and also a bend table. So, pretty busy day today. Let's talk a little bit about training. CamLogic, we offer a large variety of hands-on instruction intensive courses for users at every level. Training is available at the on-site location of your choice or at one of our training labs located throughout the Midwest. For more information or to register, please visit our website. We'd like to take a minute to mention that we do have the Solid Edge Essentials class already scheduled for June 18th through the 25th here in Oxford, Michigan. So if there's any interest there, please don't hesitate to contact us. For replays and other videos, you can visit YouTube, and they usually post within 24 hours in case you want to go back to this Tech Tuesday and revisit some things I did, and maybe double check a couple of things as well. Thank you for joining us today. If you have any questions, please feel free to email me or call me at any time. Be sure to visit our website at www.camlogic.com. We can also be found on LinkedIn, Blogger, Facebook, YouTube, and Twitter. Again, my contact information is up there on the screen. Feel free to contact me anytime. This concludes today's edition of Tech Tuesday. Thanks again for tuning in, and have a great day.